Today, I want to go back to one of the hard SQL interview questions. This is a tricky question asked by Meta not too long ago, around October 2024. This is more of a very generic solution you might come across while handling data and tables similar to a social media platform like Facebook. The title of the question is called Time Between Two Events. Let's go into the question and talk about more nitty-gritty details as we go forward. Meta or Facebook's weblogs capture every action from users starting from page loading to page scrolling. Find the user with the least amount of time between a page load and their scroll down. Your output should include the user ID, page load time, scroll down time, and time difference between the two events in seconds. So I would clearly make note of the expected output, the format of the output. Here in this case, the interviewer wants us to get the user ID, page load time, scroll down time, and the difference of the two times. Okay. A couple of quick pointers. The process, a standard template to understand the data and evaluate the edge cases is going to be very helpful. I will not go into the depth of those details today. I do want to talk about a quick brute force methodology and then dive into a more optimized solution, which is the agenda in discussing this question today. So let's quickly talk to the brute force method, and then we can dive into the more optimized method and how we can completely achieve a more readable and effective code, and also very fast to in terms of space and time complexity. Okay, so quick walkthrough of the question. Let's start with understanding the data. The very first step to before we dive into the nitty gritties. It's got a single table with three columns. User ID is the primary key. It is the most granular level information. It does have multiple days worth of data. So a single user has multiple dates. Let's take a quick preview what I mean. So if you look at user ID 0, it does have information on the 25th of April 2019, and you can scroll through and you can see data again for user ID 0, which is on the 28th of April 2019. So there are multiple days worth of data for the same user. That's something to keep in mind. So when we are computing the time difference, we might want to compute the time difference for every single date and for every single user. A couple of edge cases before diving. Okay, having said that, let's dive into some of the edge cases. This is a very crucial step. You do want to understand where your logic could fall apart and identify and be cautious about them. Okay, I believe there can be two users with the same difference in load and scroll down time. If so, we need to identify all of such users. Okay, that's what we discussed a little earlier. There are a couple of days or 3 days worth of data for the same user. We need to account for all of them while computing that average, the difference in time. Assuming no missing data. If there is missing data, that is another great clarifying question to ask. If the interviewer wants you to look into missing data, and in that case, if the page load time stamp is missing or the scroll down time stamp is missing, do you have to ignore those records or assume assume a timestamp and a default timestamp and still continue to find the time difference? So that's a good assumption to have. And if those records or the missing records need to be ignored, that's a much easier way to go forward. Okay, that's the second assumption or edge case you want to uncover and talk through the details with the interviewer. Can there be multiple loads and scroll downs on the same day? If so, do I need to solve all such instances or just focus on the first instance? This is the key assumption here. We might want to just use the first instance, because in the same day, a user could have multiple page loads and multiple scroll downs. It just becomes a little more complex in that scenario. So I would just assume for the first page load, and the first scroll down. That's my most certain information for every day and for every user. Okay, that's a key assumption to have before you dive into the solution. Okay, I have a brute force solution here. I have already written the code for the step one is very simple. We're going to get the first page load time for every user by date, and the step two is scroll down data for every user by date. And number three, we are computing the time difference between the scroll down and page load and rank the time difference to identify in the last step which user has the least time difference. I am ranking the time difference to identify the user with the least time difference. Okay, that's a kind of elaborate and brute force method we have implemented here. I do want to cut down the size of this code and implement a much stronger and more optimized solution. Let's dive into that. Okay, here I'm going to combine the page load and scroll down CTEs into one CTE. I'm going to use a self-join method here and relabel this CTE as self-join as well. Okay, CTE self-join. Okay, and then what we have is we're going to use the same table twice. T2. we're going to join on t1 dot user id, t2 dot user id, and we also need to join on the date at a date level, because every single date there could be a time difference that we can compute, and there are multiple days worth of data for every single user. Okay, so we're going to get the date information there, and for the first table we need the timestamp for page load, and the second table we need the timestamp for scroll down. Okay, and we need an additional information here just to make sure we are only looking for scenarios where scroll down time is after the page load time. There could be some errors in the data and we do not want to compute the difference, which could be going back to missing data. So I'm only going to identify T2 timestamp greater than T1 timestamp in this scenario. Okay, that's basically indicating I only want to look at scroll down information, which is post page load timestamp. Okay, so we have everything we need. In this case, we do have to designate or provide aliases. It's going to throw an ambiguity error otherwise. So we're going to compute that, and relabel these columns. The first table is helping us get the page load. The second table is helping us get the scroll down data. T2 dot timestamp as scroll down data. And now we do want to get the difference of T2 dot timestamp minus T1 dot timestamp, and we would call the difference as time difference. Okay, and of course we want to make sure this is in seconds. I'm going to just use that data type as time in order to get the seconds. Okay, now we just need to completely get rid of the step number 2. Okay, that's not needed. We already took care of that in the first step using a self join. Now for the step 2, we just need to get the rank. Okay, so we're going to change this to CTE underscore rank. We don't need aliases anymore. We are getting a single table from first CTE that we developed. We get all that information we need. No more aliases. We already got the time difference computed as well. So dense rank is also going to be very simple here. We're going to get the order by time difference, okay, as rank time difference. We don't need any of this information. We don't need the joins, just need CTE underscore self join. Okay, and no need of additional where conditions. We already took care of that in the first step. Okay, just quickly going through the whole solution one more time. The first CTE, we are getting the user ID, we are getting the page load timestamp, scroll down timestamp, that's the comma missing here, and we are getting the difference of the scroll down and page load by using a self join. We are making sure the scroll down timestamp is always greater than the page load timestamp. Using the self join, we're able to compute all that information and the time difference. We are getting the rank and in order to identify the user with the least time difference between page load and scroll down, and we are going to simply change the CTE here, which is the rank. Run this one, see if it works. Perfect, it does work. That's all. Now we have a much more optimized solution, and we completely got rid of the second step by implementing a self-join solution. That's all for now. We'll catch up soon. Thank you very much.